I'm excited to introduce our WiDS Cambridge Keynote for 2022, Professor Catherine Nakalembe. Catherine Nakalembe is an associate professor at the University of Maryland in the Department of Geographical Sciences. Her research focuses on food security and AI, specifically using Earth observation data from satellites and machine learning applications for small-scale agriculture, food security, and risk assessments. In addition, Dr. Nakalembe is the Africa Program Director for NASA Harvest, a food security and agriculture program. In this role, she uses remote sensing and machine learning to combat food insecurities throughout Africa, as well as developing early warning and disaster assessment techniques. She directly collaborates with national ministries in Uganda, Tanzania, Kenya, Rwanda, and Mali, and works with several other African nations through regional organizations. It's very impressive. Among many honors, in 2020, she was named the Africa Food Prize Laureate for her dedication to improving food security in Africa with the use of satellite observation. And even more recently, in January 2022, Dr. Nakalembe was honored with the highest civilian award, the Golden Jubilee Medal for Civilians of Uganda. As a quick reminder, this will be a 30-minute keynote with 10 minutes afterwards for Q&A, so please go ahead and enter your questions and upvote. And without further ado, I warmly welcome Dr. Catherine Nakalembe to the WiDS Cambridge 2022 conference.
Thank you so much, Erin. I'm delighted to be here, and I'm glad I listened in on the earlier panel because it made me kind of reflect on, I think one of the last comments was about what you're doing in data science. I kind of feel like I'm one of those, I sometimes refer to myself as a boundary scientist or translational scientist because I understand enough about different things in order to make sense of it and make it useful. So I'm glad to be here and to share about my work. My talk today is, I'll give a little bit of a background of why the work that I do and that we do
recording in progress
within my program is important, and primarily the applications of AI, machine learning, and accelerating some of the insights that we get from satellite data in agriculture, and specifically in sub-Saharan Africa, where my work focuses on. And recently with my colleague, Hannah Kerner, who's our machine learning lead, we worked on a sort of a summary paper on some of the reflections about, what is feasible now, as well as what is important, and some of the things that have to be considered in the world that we live in today, particularly when it comes to applications of machine learning. And so I'll talk about that a little bit. Kind of the basis or the thinking behind a lot of what I do, and I think a lot of people recognize this in the world that we live in today, that ensuring that people have food is probably one of the most primary things. I don't think anybody can function or work or think if they're hungry. And so trying to figure out how we can increase productivity at the same time minimizing negative impacts on our planet is probably the number one thing that we should all be worried about. And the consequences of this, go beyond and affect every single one of us. And so this is fundamentally the thing that I keep thinking about. And data science has a huge role to play in this, because we can't improve what we don't know how it is. We cannot really figure out how much people are being helped if we can't measure where people were and where they're going. We cannot assess how much our environment is deteriorating if we cannot keep track of it. And so there's a lot of potential there, and that's kind of where we come. My work is centered. And farming, which is, the basis or the foundation of where all our food comes from, is kind of at that intersection where there's there's a lot of opportunity, there's a lot of potential to overcome a lot of things. And it's become really important that we do it very differently. So there's a lot of information coming out about sustainable ag, and paying attention to all of those things is important, but it's important that the right people who are in positions that can make the right decisions can push for policies that can help us, go towards more sustainable agriculture. And it's kind of interesting. I like this quote because it makes us reflect. It helped me reflect a little bit on food systems, or agriculture is meant to help us get better. So when you eat well, when you eat healthy food, like I said before, you function a lot better. And so what is quite disturbing or sad is that the same system is actually destroying wildlife, destroying our environmental system on which we depend, as well as it depends on itself. And so there are certain things that have happened that need to be addressed immediately, as well as kind of thinking forward of how do we continue to feed an ever-growing population without going back to those practices that are basically compromising the earth systems. And so, and here is where I think data come in, and they're really, really critical. And the data sometimes that I think about all the time is data coming from satellite data. And so just for context, for those that might not be working with satellite data, particularly looking at Earth, we have many satellites orbiting our planet, collecting data, which we can measure a whole sorts of things: rainfall, temperature, vegetation condition, soil moisture. You can look at pollution and these really interesting things, but you can measure them for really, really large areas for the whole world, so you can understand change in every single place on Earth. And it's become much more accessible because before, very few institutions held the power to who gets to run what and who gets to analyze what and at what point. So there is a burst in accessibility to satellite data. There's a lot of free satellite data that are really important and useful, as well as with cloud computing platforms. It is possible, even for me, when I was when I'm, for example, in Mali, or when I'm in Kampala, I can analyze data that would not be possible before. I would have needed to be in my department where I can access the department cluster. And so there's a lot of potential to bring in other people whose opinions and views have not been included in, data analyses. So all of these things that we can monitor, from vegetation, from crop conditions, from pollutants, it's accessible. Another example of how you can visualize what's happening on the Earth, tracking vegetation conditions all the way on the right, the green map, looking at surface temperature, how it has changed over time, how certain summer seasons are getting hotter and hotter. You can look at all of that and analyze it for the entire world. We can look at rainfall, how the rainfall seasons transition and change. And this is really, really awesome. I can't say that enough, because I think in a lot of places, we take a lot of things for granted. So like I can use Google Maps and navigate to my house where I have an address here in Maryland. However, getting to my parents' house in Kampala, in Uganda, where I grew up, I'd have to give you directions like turn around the corner where there's this big building, because we have no street addresses. And so in context with data, this rainfall data that you can see all the way on the left, typically, you would need rainfall stations or weather stations located in a pretty, distributed pretty evenly. And this ground data are really important. So weather stations are really important, but you will find that I think the last time I checked is like one weather station per maybe 400,000 people in Africa. Yet in other places, it could be like one weather station for like 30,000 or less, for less than that. And so we have no idea how you would have from the ground, you have no idea what's happening with these very critical data that are required to understand how a growing season might evolve. If there's going to be an extreme flood, you can't forecast a lot of these things, but it is possible. There are huge steps towards being able to see these things and analyze these things and provide really as accurate as can be, of course, but very insightful information. So not zero, but somewhere where you can know for sure that this is what's happening. And with the historical data that we have, with advances in models, we can forecast really massive events. And here is one. This is Cyclone Idai that happened in Mozambique in 2019 that displaced hundreds of thousands of people and claimed many lives. The forecast, was that it was going to happen. However, because of the lack of monitoring systems in place and gaps in how do you communicate this kind of risk, get it to the people that will be impacted, and of course not having capabilities to move people out really quickly. Basically, many people were thrown in a very, very hard situation. And what is incredible is that all of this was forecast. We can measure it as accurate as possible. We can know the extent of the damage. This is an example of a map from around that time showing the increase in rainfall. At some point, it was over 300% rainfall was happening in the region. But the other thing this map also tells you is if you look up here in Kenya, you can see that there was a huge reduction in rainfall. And I show this all the time. It's pretty old, but I like it because it kind of portrays the importance of thinking more broadly, not about just your local environment, but more broadly about things that are happening around you that might impact you severely. So this cyclone pulled moisture from East Africa and at the beginning of the growing season. And by the end of this growing season in 2019 for Kenya, there was 100% crop failure in parts of central Kenya because of the cyclone, which also impacted hundreds of thousands of people, displaced many people, and an example of the level of damage. So all of this we could see with satellite data, the extent of the damage, and when you see it on the ground physically, it kind of paints this other picture of it's not just the maps, there are people on the other end of the map. So there's a lot of things to kind of reflect on. And what that means for farmers, in Mozambique, this is an example of a field that was completely destroyed right at the beginning of the harvest. And it's not a unique event. I could have spent a few minutes looking up what has been happening in 2019 and kind of documenting it with data that we have, and it would not be so different from that. And so, it's like one event after another. This is just looking at some of the events that happened in 2019, right before the pandemic started. And even during the pandemic, we had extreme rainfall, a desert locust invasion that continued it's still ongoing, actually up to today. And so there's a lot of things happening that we can, all of these things we can measure, all of these things we can see coming, or we can forecast, or we can predict. But there are lots of things that are missing that need to be done. And that's kind of where most of my work falls. And so going back to food security, I'm going to talk a little bit about the NASA Harvest program, under which I lead the Africa program. This is NASA's Agriculture and Food Security initiative, and the goal is for us to help institutions that could use those maps that I showed before have access to them, actually, because things being open and accessible means very different things depending on where you are. So just because the data are online and open access does not mean people can use them. It also does not mean they can make the right investments to get those insights that need to come out to make better decisions. And I use this as sort of the application framework. So we combine satellite imagery with time series, a combination of all the historical data that might be available. Combine it with ground data. I did mention the weather stations. They're really, really important, even though they're non-existent in many, many places where they're absolutely essential. Collecting ground data on crops, or if you're looking at things like water level, water extent, water quality, all of those things become really important. Combining those things, and in the realm of agriculture monitoring, we can extract things on crop type, crop condition, try to forecast yield, combine with temperature, rainfall, and make these really important forecasts that could inform farm management, like sowing, weeding, fertilize, harvest, harvest and stuff like that. But there's a lot of work that goes from the data to all of these applications, and a lot of these are actually really far out of reach of farmers and who have very small fields, for example, in Mali. And so the Africa program priorities are improving monitoring systems. So the maps that I show come from existing operational monitoring systems. We want to make sure that they have the newest data in them, that people can go in and analyze and download it. The second is advancing the methods that underpin the data that are in those systems. So just because we have, 250-meter resolution vegetation condition data does not mean it is the best. If something else comes available, you have to, take advantage of it, of course, and do things a little bit better. But the other is improving the quality of the products that are in those systems. So things like cropland maps, crop type maps have to be as best as possible because you don't want to, predict crop failure when the area is largely buildings because it's been converted in the last year or so. And then the other is developing and transferring capacity. So I've spent a lot of time training and working with institutions in Africa, showing people how to use data, access them. And this is where, increasing accessibility to those things. The other is developing partnerships, strong partnerships. So I work a lot with local organizations, and with them we evolve the sorts of things that we want to do together, rather than, we bring a brilliant idea and dump it on an institution, that does not have the resources to take on any new things, or, whatever it is might sound really fancy to me, but it might not meet the main objective of that organization. So trying to come up with an in-between or a place where these tools can become useful in the future or immediately, but it has to be with respect to how that organization operates. And I'll talk a little bit about that as part of some of the reflections. So this is an example of monitoring systems. We have these crop monitors that were started a couple of years ago. The initial one was called a crop monitor for AMIS. It monitors bigger producer countries. So you're looking at the US, Russia, Ukraine, India, you're looking at Brazil, Argentina. And these are countries where if there is a decline in production, as you've seen some of what's coming out in the news, there's a huge consequence. There are huge consequences to what happens in other countries that import, for example, that food. And then we have a crop monitor for early warning, which is one that focuses on countries that are at risk of food insecurity, that might, translate into poor production due to rainfall and reduced rainfall, but also would be impacted by huge global events like a drought. For example, in the US, could have huge consequences for the price of wheat in Tanzania. And so just making that connection is really important. And then from these, we built out these national systems where Uganda, Kenya, Tanzania, Rwanda, Ethiopia have their own equivalent where they integrate their own information. And so we try to make sure that these systems work really well. They're up to date. When a new web service, comes available that makes it a little bit cheaper or faster, runs better, we try to, make sure that the system is up to speed with that. And then so advancing the methods, I've already spoken about this, making sure that the maps are as accurate as can be, that they're using, cutting edge, they're based on cutting edge research, and we do a lot of that. Developing and transferring capacity, I've already spoken about this. And then as well as provide a little bit of detail on the partnerships that we have. And so in terms of the, for the next part, I would just talk about what we think about as, what are the applications that are really important for farmers in sub-Saharan Africa, as well as what are some considerations to think about in a broader context of living in a global world, one that's trying to advance and make the world better together, I guess, if I put it that way. So, so these are some of the key applications. And this is, I think, more for, if you're not familiar about how satellite data are used in agriculture monitoring. So I'll give some examples, as well as just focus on those machine learning or AI applications that would be useful and directly accessible to smallholder farmers, or could lead into policy decisions that can help smallholder farmers. So when things I'll talk about will not include things like self-driving tractors, because these might not be accessible, these are not accessible to over like 90% of smallholder farmers. For example, I will not be talking about, irrigation scheduling, which you can also do because, it's also still far out of reach. So I'll just talk about those kind of the key things. And some of them, we have cropland crop type maps. They might not seem like they're directly useful to farmers. However, once we have information about where crops are growing, if we have it over a couple of years, if we have it within the growing season, we can assess how crops are doing. And then from that, you can determine whether or not an area has been severely impacted by an extreme event, and if there needs to be some response. So without an updated crop land map, it will be impossible to tell the extent of the damage of, for example, that cyclone Idai that I mentioned before. In terms of another example, for example, looking at specifically crop type mapping, if you want to understand increase in production of, let's say, maize over time, you will need to be able to extract that information. It's complementary in the sense that once you have examples of what yield is in a specific field, combining it with satellite data, you can kind of model it for a much larger area and get a lot better grasp of what's happening in a much larger area. There are things like field boundary delineation. So with segmentation approaches, for example, you can extract these boundaries over larger areas. If you want to measure and understand yield, as I mentioned before, or if you wanted to go further down the road into like fertilizer application, you want to be able to have these boundaries, as well as going further into like yield estimation, which is the next one. So combining satellite data to be able to model yield over larger areas is probably one of the most important, most promising, as well as being able to forecast early where things might not go so well. The other is disease, pest detection, trying to be able to understand how a certain disease is spreading in an area. So if you're looking at things like fall armyworm that wipe out, an entire season's crop for a farmer, if you want to deal with that, you want to know really early. So trying to complement ground-based detection of these, people taking pictures of a pest and trying to model how it might spread in an area is important and absolutely critical, because when these events happen, sometimes you find that it's almost 80-90% of a harvest is wiped out. And so for the considerations, so what are those things that are important to consider as we are developing tools for supporting agriculture development, and particularly in sub-Saharan Africa? I think from the previous panel, there was also a discussion about maybe a point was made about saying things that AI can do when it cannot do it. So those sorts of things are things that I kind of like reflect on and talk about all the time. One is, most importantly, and we just use these pictures out of convenience, but we could have like a much bigger number of pictures, is just having interdisciplinary teams. And so just because you can run a classification or you can run a model for something does not make you an expert in agriculture or soil management or agronomy. And so working with people who know these things is really important. So we work with not only extension agents who can literally tell you what you're looking at in a field, but we work with students and researchers, and in all the countries where we're working, we have like on the ground teams who know, what is supposed to be done within the season, and then translating that knowledge back into maybe the crop monitor system. Like, at what point do you report on what is important? The other is considering the resource context. So when I'm in the US, I never worry about internet connectivity or data connectivity. When I'm in Uganda or Mali, I'm constantly adding money to my cell phone to be able to do something. And so the cost, could prohibit the existence or the usability or utility of a solution that you might develop. So, it's important to think about that. And when we talk about something being fantastic, if it's fantastic in the United States because I have high-speed internet, but when I go somewhere and I load it, it does not work, then it is not fantastic. It's the exact opposite. Working with stakeholders from the beginning, I did talk about this a little bit, just to make sure that what it is you're developing, if it is to meet a need, you have to understand what the need is, rather than being like, well, I've seen this being done this way and it should work that way, is probably not the right way to go about it. And so from a more technical perspective, I did talk about the weather stations a little bit, but this goes, even in other things. So in order to be able to test, deploy massive models, we need to have training data. And when you look at a lot of, these very promising use cases, and start to explore running a certain model somewhere, you find that a lot of the training data come from very specific regions. So if you're looking at things like YOLO, for example, like if you look at all the images, where they're from, they're not representative of a lot of places. And in the case for, agriculture, we, run into the situation where we don't have a decent amount of training data. And I use decent because, I don't know what's the best or the minimum or the maximum, because we're dealing with a very complex, very heterogeneous system where we need a lot of labels to be able to come up with really good models. And the other is, being transparent, going back to a point that was made in, I think in the panel before. Having transparent and reproducible things is really important, so others can use them, so others can learn from them. Being able to document, make things accessible to others is really critical. But this also goes back to the point on the resource context. So it could be reproducible here, but if it's for an end user somewhere else, would it be reproducible if it runs on a computing, if it requires a computing cluster, for example? The other is, within research, particularly scientific research that requires learning from other systems or other places, is falls, I'm going to use the word falls victim of, not being respectful of, our study subjects or the regions where we're working. And so you find situations where researchers, for example, in Africa, are involved in research from which they don't get any credit from, or they're not paid appropriately. Sometimes we use labels, for example, but the cost of collecting labels and the manual labor that's associated with it has to be, acknowledged and has to be compensated for and paid for. And treating people as, I feel like doing ground data collection is much harder than running a model or analyzing data. So, recognizing that is really, really important. The other is that technical solutions might not be the right solution or might not be the appropriate solution. It might be more a social context solution. So just being able to think about those things as we're doing our work is important. And some of those ways to go about that is, for example, forming meaningful partnerships. So working with people as real partners on some of the work that you do. I show this, the graphic on the left. It's one of my favorite projects where we're collecting ground data in 5 countries, and all the work is led by local institutions. They have their own very small grant, and each one of them decides how they want to approach it. and then we aggregate the data, work together. Basically, we're solving the problems with them as we go. The other is having investments in institutions. So I always think about this also from the perspective of, end user organizations should not have a huge dependency on the people who are bringing the solutions, but make investments to take advantage of those solutions themselves and kind of build up to them. For smallholder agriculture, we need very high resolution data. We cannot say this enough for things like field boundary delineation. There also needs to be higher frequency. And so there has to be, thinking about how can we make the data that are required to study this landscape more accessible and available. The other is being able to communicate the limitations of our data products, our tools, and our models. I showed the image on the top right, because I think the assumption when people think about AI, ML, and agriculture, you always think about, oh wow, you can just come with your tablet and know everything about a field. All of these things are actually, in many cases, 90% of the case in sub-Saharan Africa, in smallholder fields, impossible because we don't have the tools or the instruments in the ground to tell us from which you would build the model to get that information out. And I think this is probably next to my last slide, just talking about opportunities. So with all of those things, reflecting on all of those things, working with people as equal partners, working and supporting local collaborators, there are really, really great opportunities. So we have a lot of really interesting problems that we need help with. And if if any of these things seemed interesting to anybody, please reach out. We need methods, for example, to work within this data scarce situations to produce high quality products that are needed for improving decision-making systems. There's complexity that we have to deal with. This is really a challenging thing. We have to fuse a lot of data, be it from cell phones, be it from multiple satellite data sets, be it from both temporally and spatially. So there's really, I'd say that there are really some really cool, really challenging things to look at. More efficient and scalable techniques. I can't say that enough, because once you've invested a lot in building a really good model in one country, it could be really useful for another. And it will be important that the front end investment is not the same for when you're scaling the model, which will make it easier to make it available to other users who might not have the resources to invest upfront, or there might not be a grant to support that kind of work. There's a huge desire from local researchers. I can't say enough. There's so many really interested young researchers who are passionate and excited about things like data science, remote sensing. They're interested in just learning how to work in a global world if the world opens up to them. So, we have to kind of think about that as we think about our work as well. And the other is just having data sets and benchmarks that are representative of the broader world. So while we have very promising models for detecting cars in the US, maybe we need models for detecting cows in India, for example. That is my last slide. And I wanted to show this. It's my favorite photograph from fieldwork from many, many years ago with a farmer in Tanzania, in Njombe. And she was showing us what field was maize. This was her first time using a computer, looking at a satellite image, and she was able to point us to what field is maize. So I just show this because I think it's important to kind of reflect on what end users or the person you might not think has information has the very information that you are looking for. Thank you.
Wow, thank you so much. Thank you for such a wonderful talk. We've got a couple of questions, but first I wanted to ask, you had talked a lot about being able to do weather predictions and be able to, predict the climate change. Have you been able to measure how farmers have made decisions as far as maybe planting different crops because they see some of maybe these insects coming in, or it's benefited them more economically based on the satellite data that you've been able to provide?
So this is a very good question. It's a very interesting question because it has answers in both directions, in many directions. One of the directions is sometimes we have very good insights that are very promising, but what ends up happening is the farmer does not have the resource to implement that thing that could see them out of, whatever the consequences of what's unfolding. For example, we can predict that maize yield in northeastern Tanzania has continued to decline in the last 5 years due to a lot of variability in rainfall. But the farmers in northern Tanzania do not have anything to help them switch out of maize or growing something else that might be more lucrative, because there's a whole bunch of other things that have to exist in order for them to be able to benefit from it. For example, a market for where they would sell the new crop, seeds for where they would get the seeds for that crop. But in terms of some of the other things that might be really promising and interesting attempts at things like what is called disaster risk financing, where there is a structure that if something is going to happen or that farmers will not be able to survive, there's an alternative means that can help them get through that season. The other would be, programming that would help farmers access seeds that would be more climate resilient, So if you're in an area in the Northeast where there's a huge decline, but there's been a certain kind of crop that seems to work really, really well, a seed that's been tested from an ag research station, making that available at shops where farmers buy the seeds is some of the ways to address this. But I think even with all the fancy, really fantastic promises that we can see all of these things unfolding, without the policy structure or the thinking around making these things accessible, will not make it, does not result into that very, very positive outcome that we all hope for. It's like knowing that cover cropping is essential for not only improving soils and productivity within fields in the United States. If it's not incentivized or made accessible to farmers to do the switch, the farmers won't do that switch either.
Well, then as a follow-up, what kind of role do you think that industry needs to play? So you've got good participation from national governments and from some regional governments and organizations, but then, do you think that industry has maybe a greater role that they could contribute in this?
Absolutely. I think one is running really quickly with the solutions and making those solutions accessible. So there's a lot of companies and you could say ag tech, who are using those insights to bundle this. They call it bundling services. So if you buy this seed, we'll insure it for you. If things go bad, we will pay you out, and then things can work out in the future. But also sometimes scaling things really, really rapidly, which a lot of government institutions might not be able to do. The other is trying things really, really quickly. So by the time a policy or a law gets passed, so many years have passed. But within a company, incentivizing something might be, it might be pretty straightforward, because I feel like farmers could subscribe to that service, which could see them through a very difficult time. Yet the government policy is going to happen, 5-10 years. They have to discuss it, think about it. And by the time they're done thinking about it, that technology is ancient. So, it's kind of the public and private partnerships are absolutely critical. In this case, yeah.
Probably also access to capital and not.
Absolutely, yes, not capital and directing people to invest in the right things. I mean, it's also a double-edged sword in the sense that the private, it might kind of further disadvantage the farmers. So you added a whole other power structure. A private company has more money. and if they're for profit, trying to serve a largely underserved community, all of those things kind of continue to translate. So I always say this when I thinking about ensuring like smallholder farmers, the power structure is insane. It's like, David against Goliath. And if a farmer really needs to be paid out, like who will advocate for them, and who is out there watching the farmer get their fair pay? And if this is driven, by a for-profit company, you can see how the problem can, further disadvantage the farmer. And that's where some sort of governance to make sure that people are actually protected in situations like these is absolutely important.
Well, one question from our audience is, how can Western and other strong industrial countries support this work and the world adopting more agriculture and food industry to combat climate change? So kind of what can then others outside of national governments, local organizations, NASA, I guess, your work, but, is there something else that that industrialized countries can do?
I think one is first reflecting on the inside as well. There's a lot of unsustainable practices that need to be addressed. Conversion from large-scale agriculture to more small, sustainable things need to happen. Even within countries, farmers have to be protected too in the United States. But I think if you're thinking about it from a smallholder context, one is helping overcome that power structure where they're not always on the short end of the stick. In every single consequence, when there's a flood, when there's a drought, when there's crop failure, it's happening in those same areas where people don't have access to resources or support, or they just get being drawn back, in worse and worse situation. I think it requires fundamentally being able to come up with ways of supporting farmers, and there's so many levels of things that are so complex that there isn't, I think, a one single thing that I can think of that could be done directly, except maybe push for more concerted, regulated support systems where there are institutions that can support the farmer. I kind of feel like from my experience doing field work, farmers are literally all on their own, and it doesn't seem like anybody cares, just generally, about their struggles, and they're working really, really hard. And I think through these groups that they form, they become part of a community and they feel more supported, as extension agents or a group of farmers. But trying to figure out a way of getting them that kind of backing or backup so that they're not like always facing against giants. The giant could be a cyclone, but it could also be an insurance company, or it could be a seed company, or it could be a company that makes loans to farmers. Like those, these giants that make this incredible power structure completely unfair. Yeah.
There's so much more that we could get into today. This is such a fascinating work. Thank you so much for sharing. I will end with, we have people that are interested in finding out more information to some of the questions about agriculture on sub-Saharan Africa and NASA Harvest. So probably the website is a good place to point them, but anything else, any other recommendations?
So some of the work that, where if you're thinking about, if the interest is like data science, like we're really interested in having really smart people help us solve these very complex problems. Sometimes we have, I give an example. We have a lot of data that we've been collecting. We're trying this, like we're taking images as we drive. We want to take pictures of crops so we can label them really quickly. So we have like, let's say 1 million photographs. And we're trying to use, computer vision approaches to label those images. We have to figure out a whole bunch of other things so that it can be scaled. But there's also things like we have a lot of students. I have a lot of students who reach out to me who need guidance on data science careers. How can they study? What should they study? Where should they go? And so those things are also incredibly overwhelming. But there's like there are lots of really interesting questions. I can say that if you're interested, be it looking at soil texture, using soil data, we can look into all of those things. We have work that's ongoing even in the US, in France, and all sorts of really interesting, all sorts of really interesting things. But the website is a really good place to start, and as well as NASA have his website, you can check it out. You can see some of the current projects. Some of them might not be on there, but maybe we'll assemble a really good site or page that kind of talks about the problems we're trying to solve with AI and machine learning and data science that you can check out.
That's an excellent plug. It sounds like you've got a lot of time on your hands too. So, all right, we're gonna, I just want to, again, thank you from a very heartfelt thanks, Dr. Nakalembe, for your wonderful talk. And if we have some questions, we may relay those to you. Thanks.